Hello, everyone, and welcome to another episode of TechHub.training. Today, we'll be going over the Fraudster Finder Challenge in the Python Learning Path document. So I'll go ahead and read this cell to get the data frames that we need. Notice we're transforming this into a datetime object using pd.datetime, reading it in using that, and then we're creating three separate data frames out of the master data frame based on the transaction type. Great. So here's a quick example of kind of the stuff we'll be doing. This just shows the matplotlib of receipts included or receipts not included, and the median transaction amount associated with that. So as we can see, there's a larger median transaction amount for people who are not including their receipts, which is a warning flag. It's a red flag for sure. Next thing we want to do is make a box plot. What we're going to be using is the column from the data frame called amount. That's what we're going to be investigating. So to do that, we'll just say plt.boxplot and put that column in as the argument. Here you can just put in titles and whatever else you like. We can see that there's a significant amount of outliers. So we want to go and investigate those further. So we're going to want to kind of filter the data frame to only those rows in which the transaction amount is greater than this upper bound. So we'll go over how to calculate that. It's the inner quartile. It's going to be 1.5 times the inner quartile range plus the third quartile, which is just right here, right? To get those quartiles outside of the graph, you can just say quantile 0.25 and quantile 0.75. So that's going to get the percentile of those two things. So the first quarter 0.25 and the third quarter. Then you use that to calculate inner quartile range, and then you can get the upper bound that way. And then we'll just filter it and say our new data frame called bad apples will equal the rows in data frame in which the column amount is greater than the upper bound. So we get that data frame. Interestingly enough, only one employee is making all those outlier transactions, and they're all being approved by the same manager. So let's look at that. We'll make a new data frame called manager counts, and we'll go ahead and apply dot value counts to the approver column. And what that'll do is just take every unique instance of approver and then show how many times it appears in the data frame. So pretty easy. Pretty simple process right there. We'll pass that argument to plt.bar to make a bar chart, and we'll use the index, which will just be every single approver, and then we'll use the values, which will be however many times it appears in our original data frame. And that'll show us how many the number of transactions approved by each manager. Here's manager D right here. So he's approving relatively few. Let's look at the average transactions. We'll use a group by function there. So when we take the average amounts, when we're trying to find the average amounts, we'll make a new data frame called average amounts, and we'll apply the group by function to df. The group by function will take approver as an argument, right? And what that means is we're taking the column approver and we're saying, okay, like, we're for each approver, for each unique instance of a different approver in the group or in the data frame, we're going to want to find the amount of each transaction, and then we're going to want to find the average of all those transactions associated with each individual approver. So then we'll plot that again. We'll pass those same things. So we'll take the average amounts df. We'll pass the index as the x and the values as the y. The reason why this says plt.bar label instead of just plt.bar is we're just putting these labels up at the top. It can be pretty helpful. Just be careful because the plt.bar label function will take the plt.bar as an argument. So it's pretty easy, pretty simple, but if you don't have to, you don't need to. It's not necessary, but it can be helpful for us when we're looking for specific numbers, something generally to leave off in customer visualizations. Again, you'll just title it, label it, however you like, and we'll get this right here. So we can see that manager D is approving very large average transactions. So we'll go ahead and filter the data frame, and we can just do that by data frame brackets data frame brackets column equals what we're trying to get it to equal, which is going to be manager D. And so the manager D data frame, which is just all of the transactions which he's involved in, is pretty small. It's actually the exact same as the bad apples data frame. So all of his transactions have been outliers. Kind of interesting, something to pass on to our boss. Before we pass all this information on to our boss to have him investigate Emma and manager D, we want to see if there's any other fraudulent transactions or possibilities of those. So we'll take our three data frames that we split at the very beginning, credit card, reimbursement, and invoice, and we're going to make a histogram for each of those. So we'll just use plt.hist. As an argument, it'll take the column that we're doing. So it's going to be the amount column of each individual data frame that we're doing, right? So We'll see that down here. And then the number of bins. Bins is just the number of columns you want the histogram to have, right? So in this case, it'll have 20. It's like a good round number. Make sure that we're not, getting our data too specific that we can't see anything or any general trends, but not too general that everything kind of merges together. We'll set the colors equal to what we said, and then we'll do those labels like we talked about. You can set those, to whatever you want. Those are just to make it look nice for our boss. And we could see those outliers again here in reimbursement amounts. So it looks like those are all reimbursable transactions, kind of interesting. But we can't see a ton because of those outliers. If we look at the credit card amounts, however, we can see that there's a big spike around 500, and the same is true for the invoice amount. So we might want to bring that up to our boss. Maybe there's a limit around 500, and that's causing people to crowd up against that upper limit, something like that. So something to bring up to our boss. It might be nothing, but it might also be an opportunity for people to commit fraud. Next, we want to look at the patterns we can determine with time. So we're just going to make another histogram, but this time based on time. When we do that, we're going to take a new data frame, a new series, and that series is just going to be hours, and that's just going to be equal to df, the data frame, the original master data frame, the column time, and then we're going to apply the package date time to it, so .dt, and then from that package we'll apply hour, and that's just going to extract the hour component from the time column. So now we have a series, which is similar to a list, that's basically just the hour timestamp of every transaction. So we'll put that into PLT hist as the first argument. We'll put 24 bins because we want one for every hour in the day. The range we're going to set equal to 0 to 24 as well, because we know we want one for every hour in the day. We don't want them to randomly make the bins or assign the bins. We want it to be 0 to 1 a.m., 1 a.m. to 2 a.m., 3 a.m. to 3 p.m., et cetera, et cetera. And when we do all that, we get a graph that looks like this. So some strange transactions going on around 1 to 4 a.m. Maybe something to look at there as well, probably something to check on for us. It could also be just a recurring transactions that happen every once in a while with a vendor, and they just send us the bill. It's automatically generated and paid every day or every week at a certain time, and that time just happens to be 2 a.m. Could also be something going on or in a different time zone if we have some kind of international subsidiary or something like that, but definitely something to bring to the attention of our boss. Yeah, that's all we have for today. Hope you enjoyed the solution video. Hope you enjoyed the colors as well. We did set them up so they matched the big 4 accounting firms. I don't know if you picked up on that, but just a fun little Easter egg we put in there for you. Let us know if you have any questions on the learning path, and we'd be happy to help. Thanks for watching.